So let's start today's session. Today we are going to study about multi-tenant architecture. Okay. So let me verify what are the database that is running here. So yesterday what we have created enable database which is running, and it is running with ASM repository where all the data files are associated. Okay. So let me log into this database. Pura env enapblle and SQL plus SSDBA. Since this was a multi-tenant database, right? We have created one pluggable database as well for this. So how to identify how many pluggable database is there? Okay, so inside, as a layman, you should understand as of now, like inside one container database, there can be multiple pluggable database. Okay, where we can plug in the database inside a container database. So inside one container database, there can be multiple pluggable database. You can configure also, or during the installation, you can create as well. Okay, and if something bad happens to the pluggable database, you can restore that database as well. Okay, so as of now, in the last session, while doing the installation, we have created one PDB, and the name of that PDB was ENABLEE PDB, right? You might guys have remember that thing. There was an option to select a PDB, isn't it? The first thing that came to your mind, like how to check how many PDBs are there in the database, or whether the database is being configured with a multi-tenant architecture. Okay, so with the command show PDBs, if you'll hit this command show PDBs, you'll be identifying that how many PDBs are there associated with the container database. Okay. So as of now, we are in the container database. Container database is the mother database inside which n number of child database are present. And a child database is known as pluggable database, and the mother database will be known as container database. Okay. So what is the command to check the database name and all that? Open mode from log mode from GB dollar or V dollar database. Okay. If this database is in rack instance, so we can identify that whether it is in rack or not also, okay, with the help of in gv command. So look, this is the database name is enable. It is in read write state, and archive log is also enabled. Now, suppose we'll check the parameter, show parameter name. So you can identify that the database name is also enabled, database unique name is also enabled, database instance name is enabled, and the service name is also enabled, isn't it? But we are very much sure that this is a container database. This is the mother database. And inside this database, there can be multiple pluggable database. So we are logged in. How we used to log in, like SQL plus SSDBA. So on that database, where we have logged in is a container database. And how many pluggable database are there? With the help of show PDBs command, you can identify it. Okay. So this is the command from which we can identify how many pluggable database are there. So pluggable database enable PDB. This is the pluggable database name. And the open state is mounted. Now you are in doubt, like what do your PDB seeds and all that, right? Why it is in read-only mode? This is the new thing that you have observed right now. But forget about that. When we'll start with the theoretical part, we'll let you know what are the things that resides in the PDB seed and all that. But as a layman, you should know there can be one container database. Inside one container database, there can be multiple pluggable database. So say you can say that this is a container database, what we call as a CDB. Okay. Container database. Okay. And inside this, if you are seeing this thing, right, like this part is termed as CDB dollar root. I'll come to this part also. What do you mean by CDB dollar root and all that? The attached part, this part will known as PDB dollar seed. Okay. And this two, inside one container database, there is pluggable database named as PDB1 or PDB2. If there are multiple PDBs, so it can be PDB3, PDB4, and it will move on. Okay. So this is how the structure looks like. Inside one container database, there can be multiple databases associated with. But there is two important parameters that has been added here is CDB dollar root and PDB dollar seed. Apart from that, there is nothing in this multi-tenant architecture, but this is a simple diagram, which you should understand that inside one container database, there can be multiple pluggable database. Okay. So earlier, how we used to log into the database, like this is our single standalone server. Okay. So in this database, suppose this database name is ORCL, and we used to log in like we used to set the environment, SQL plus SSDBA, right? And you'll be getting the SQL prompt and you start working with the database activities, isn't it? But If this database has a multi-tenant architecture, that means this is a database name, what we call as a container database. And in this database only, inside this database only, we have pluggable database. You can say ORCL1, ProdDB, or multiple name you can give depending on the configuration, how much PDBs you want to configure it. Okay. So you can see here is like we have one database named as ORCL. Inside this, we have a database called ORCL1. So this ORCL is known as pluggable database. This prod is known as pluggable database. And the mother database is known as container database. So you can see here is like we have login to the container database using this normal command. But you will be seeing like how much PDBs has been configured, whether the database is in multi-tenant architecture or not. With the help of the command show PDBs, you can identify what are the databases name, how much data PDBs are associated with, and what is the database state, whether it is in mounted state, open mode, read write, okay, no mount. Each and every state you can identify with the help of the simple command show PDBs. Okay. Now you'll be asking like we have a container database and we have a pluggable database also. How to log in it to pluggable, isn't it? So you can make it a note, okay, so that you guys won't be forgetting it. So this is a command show PDBs. This was the output we have got. Okay. Now suppose this is a pluggable database and now I want to log into this pluggable database. So there is a simple command called alter session set container equal to enable and the database name. Okay. Enable PDB. This is the pluggable database name. You have to mention it. And the command to log into this pluggable database is alter session set container equal to enable PDB. If you trigger enter, you'll be getting session altered as a output. And if you want to again validate like what is the database name, so if you use show PDBs, you'll be getting only one name, right? Earlier, this command is showing the two names like PDB seed as well as enable PDB. But now, once we have logged into the PDB name, PDB database, you are seeing that only PDB name is showing here, isn't it? Why it is so? This is because we have successfully logged into the pluggable database. This is the only thing you have to learn, like how to check the PDB's name and how to log into an individual PDB. Okay. Once you are successfully logged into this PDB, the rest of the work is same what we used to do in the single standalone server. Like this database is in mounted state, isn't it? What is the command to open it? Alter database open, right? This is the command what we use to in the single standalone server. Oh, let me check. Database altered. If you'll trigger this command again, show PDBs. Look, what is the difference you are seeing here? Earlier, the open mode was mounted. Now it is in read write mode. So to start working on a database like PDB, so you have to make sure that database is in read write state. Then only you can work on it. Same as single standalone server. You can't start your data. You can't create the data files and all that in the mounted state, whether working on the single standalone server. Okay. Similarly, if you have logged into the PDBs, you have to start your pluggable database as well. If you won't start the pluggable database, you won't be able to work on this particular database. How much pluggable database you can make it in read-write state? Okay, yes, this is the question. Yes. So let's say we have 4 pluggable database in this server. Okay, in this server we have 4 pluggable database, and all the 4 pluggable database can be in read-write state. There's no restriction, no foundation. So the first thing we'll start with the multi-tenant architecture is, which is similar to standalone, like how you will identify about the ADR location. How can you identify about the ADR location? RDB means admin going to that location and you can identify it, right? But if you, this question will be asked in your interview, you have a log file location with the views, like select star from v$diag_info. Okay. If you'll use this command, okay. So what command I have used here is select star from v$diag_info. So with this command, you can identify if there can be multiple PDBs or multiple CDBs. There can be the CDB as well as the multiple PDBs. So for all the PDBs and CDB, you will be identifying the alert location of each and every one. CDump location, health monitor location, Oracle home, Oracle base. Okay, each and everything you can identify with this command. Select star from v$diag_info. We are always aware like how to go to that alert log location. Go to Oracle base, RDBMS admin, database name, SID, trace, and alert log, right? But you don't have to worry about that. That is not the case like in all organization, the same path will be there. No, So the path can be different. So to identify it very cautiously, you have to trigger this command v$diag_info, and the location you'll be getting over there.
Okay.
Similarly, we have this ASM in place right now, right? So ASM is also having some type of logs, because ASM is also an instance. ASM is also having a parameter file. To identify any issues related to ASM, we should have alert log also for ASM. We have already validated it in the past session. So how to log into this ASM log file? So what you have to do is first set the environment, go to grid user, oracle.orinv ASM, and you have to trigger this command pwd. Look, U01 app grid. This is what we call as a Oracle base or grid base, isn't it? Under grid home, there is a directory called diag, under which we have CRS. Okay. And ls-ltrh, if we'll do this, ls-ltrh, we will be getting the host name for that particular server. We'll go to that host name, ls-ltrh. You'll be getting a CRS. Go to that CRS, ls-ltrh. You'll be getting a number of files. Look. So under trace, we have the alert log file, CDUM file, incident files, sweep file, stage file. So trace is a file. So let me do ls. Okay. And we have multiple TRM file and TRC file here, isn't it? And we have alert log file also in this. Where is the alert log file? ls-ltrh, ls-ltrh alert star.log. So this is the alert log which is present here in the server. Okay. But we have different directories as well, like this alert. Why this alert is present here? Since this is a directory and it is having log.xml file, but alert log file is in different directory, which is in the trace. Why it is so? What is the importance of CDUM here is incident, log, and all that. No idea? So not to worry. So whenever you are working on a database, make sure that the alert log location will be under trace. Okay, it is Oracle recommended. We are not aware why they have used that thing. And the alert, this alert consists of XML files, and this XML files also generates on the regular basis and captures the records. What is the suspicious thing that is happening on this database? But this XML file, you won't be able to read it, isn't it? It is very difficult for us to identify it, that because there can be multiple contents that has been written in the XML files, and it is not in the suitable format as well. So why it is present in this database if it is not used for a DBA? Because if anything, you are not able to track it from your alert log file, you have to raise a concern with the vendor, Oracle vendor, isn't it? Oracle vendor will ask you that what is the database name, what is the issue, and they will ask some details from your side. And that details means they want your alert log file. They want this .xml file also, because they will track these XML files and they will identify, okay, what is the issue, actual cause of that issue. Okay. So you need not to worry about this, how to read this XML file. This is used by Oracle vendors only. They have the software intact. They will place this XML file on that software and they will identify that, okay, this is the issue, this is the reason, and what is the resolution step. They will share you in Metallic website. Okay. This is the functionality why these many directories and files are present in this location. So sometimes CDUM log file is also asked by Oracle. Sometimes trace TRC and TRM file is also asked by the Oracle vendor. So that is why n number of files have been generated. Most of the times you have to give that logs to the Oracle vendor, and you have some trace files or alert log file to identify the root cause and issue for your database, for your real-time troubleshooting.